Okay, so let's just quickly reintroduce you to JASP. You should have used this program in your first year for your research methods module there, and you may have used it in other modules as well. Let's just very quickly go through how the program works so you can kind of navigate it more easily. And we're going to go through some very basic descriptive analysis of data just to help you familiarise yourself with the program in this video. In later videos, we'll move on to the kinds of analyses that you can do for different study designs, and I'll do some practical examples to show you the equivalence between the general linear model or a linear regression model and the named statistical tests that you often encounter. So to start off with, this is the screen that you get when you open up JASP. So you have the main introduction, and then you have up in the top left corner the three blue lines of the main menu. You can create new data in JASP if you want, although it's advised typically that you would use something like Excel to input your data and then save that as a CSV file. I'll go over that in just a moment. And then you have these different modules. So when you have data open in JASP, you can access these different modules to conduct various different kinds of analyses, plots, etc. You can also add new modules using the plus button on the right hand side here, and there are a variety of more advanced statistical analyses that you can use using these new modules that have been added to JASP. Okay, very quickly, let me just give you an example of the data and how it needs to be structured in order to read it into JASP to do any analysis. So I'm going to open up an example spreadsheet here. So what we have is, let me just zoom in, some data. We have four variables: group, variable 1, 2 and 3, and then we have a number of observations for them. So we've got 50 data points here. Now, when you are saving and importing data into JASP for analysis, it needs to be saved as what is known as a CSV file, or a comma-separated values file. In Excel, if you input your data, you can save it as this file type if you go to save, and then you can, for example, change it to this .csv file type. Now, it's important that in terms of the structure of the actual file, you have to follow the, make sure you adhere to the following principles. So the first row in your spreadsheet must always only contain the names of the columns in your spreadsheet. And these will typically be the names of the variables. So for example, we've got this first column which is named group, and that is in row 1. Column B is variable 1, column C variable 2, column D variable 3. In this first row, you should only ever include the names of your variables. The remaining rows and columns and the cells that form those are where the data goes. So for example, in group we've got either 1 or 2, so that indicates which group that row of data belongs to. And then we've got, for 3 different variables, the values of those variables. So it's important that you make sure that your data is always structured this way, because when you then read it into JASP, it will automatically recognize each of the variables in your data set. Okay, let's close that, and then let's open it in JASP. So depending upon where you've saved it, there is a zip file on the sole page which has got all of the example data sets for use with the JASP student guidebook, which is also linked on the sole page as well. So depending upon where you've saved them, you'll need to go to the Data for Handbook upload folder, and then we're going to open up the Exploring Data file, which is just that one that I had open there. So you can see now that JASP has automatically recognised that the first row was the column names, and then it has readjusted the row numbers so that all the data is what was below those names in that CSV file in that spreadsheet. Now, when you look at data types, you'll see these little icons appear next to them, and these also indicate the type of data it is. JASP does a pretty good job of indicating or automatically identifying these, although sometimes you might need to change them. In order to do that, you can go in, double click on it, and go to column type, and you can change it to nominal, ordinal, or scale, which is interval or ratio data. There's a number of other things you can do in this as well, but I'll leave that for you to explore and play around with. Okay, so once we've got the data in here, we can do various things with it. And as I said, we're going to have a quick look at some descriptive analysis with this. Now, one of the important things as well that you can do in JASP is that if, for example, you notice that when you're doing your analysis there is an error in some of your data here, you can leave JASP open and you can go and open the CSV file that you read into it, make changes in that file, save it, and then it will automatically upload in here. So you don't need to make changes in both places. You can make changes in the raw data file. In fact, you should always make sure that you don't kind of like duplicate your data editing. So let's have a quick look at descriptives. So when we click on the descriptives module, we see the data disappears, but it hasn't really disappeared. It's just been hidden behind these two windows that appear. So we have a window which has the various options for the analysis that we can do and what kinds of variables we want to look at. And then we have our output window on the right-hand side here. So you can see we've got results and we've got a descriptive statistics box. So let's, for example, pop the free variables that we've got over into our variables column. And you'll see what it does is it automatically, for each of those variables, calculates a number of descriptive statistics for us. So it tells us how many observations we have, whether there's any missing values, what the means are, the standard deviations, the minimums, and the maximums. But we've obviously got two groups in this data set, so we can also split our data according to group. So now you see if I do that, it automatically updates it. We see that we've got 24 in one group, 26 in another group, and it separately calculates all of these things for each of the groups. See how much easier it is to do this than messing around in Excel with formulas and so on. Now, if our table, for example, has lots of variables in it, we can actually click on transpose and we can make that a little bit more easy to read. But for the moment, we're going to leave it as it is here. Okay, let's just look at some very basic statistics that you can do. You can also do a number of plots in this as well and create tables and whatnot, but I'll leave again you to explore that. Also because when you do the other kinds of analyses, there are plotting options in those modules as well. So, for example, we can look at different measures of central tendency. So typically, if we're looking at scale variables, we would look at something like the mean, or if our data is kind of skewed, then we might look at something like the median. If we look at the median, we might want to also look at the interquartile range. And you see, as we add these options in, it automatically updates our results table with them. Now, one thing I want to point out here, which is just a misnomer which often gets taught in statistics modules, is you will often hear that the differences between parametric statistics and non-parametric statistics, which you will have noticed I mentioned in the previous lectures, are whether or not the data is normally distributed. So parametric statistics make assumptions that the data, or so it's said, that make assumptions that the data comes from a normal distribution, and we can test to see whether that data meets that assumption of normality of distribution. Non-parametric statistics are typically used when the data does not meet those assumptions. However, this is a little bit of a misnomer. It is not whether the data meet those assumptions, but whether the residuals in the linear model meet those assumptions, meet that assumption of normality. So what you'll often get taught is that you can come in and do something like the Shapiro-Wilk test here, which is a test for normality of distribution. And you see we now have a Shapiro-Wilk test statistic, and we also have what's called a p-value for the Shapiro-Wilk test. Now, to give you a quick definition, which you will have noted from the Daniel Larkin's video on the Sol page as well, a p-value is basically the probability that we would observe this data or more extreme data if we were to assume the null model was true. And in this case, the null model is that the data comes from a normal distribution. So, typically we use some sort of threshold for making decisions about whether or not we can reject the null hypothesis or the null model, and typically this would be something like a p-value of less than 0.05. So if in this case we had a p-value less than 0.05, as we do for example for variable 1 and group 2, we might say that this data we can reject the assumption that the data comes from a normal distribution. But you should note that this doesn't necessarily mean that we can't use parametric statistics on this kind of data. Situations where you do want to use parametric statistics are when the assumptions of your regression model, your general linear model, have been don't appear to be met, and so that, for example, is when the normality of the residuals is not met. If you have data such as ordinal data, so for example if you've collected Likert scale data, then those are situations when you would want to use a non-parametric test because it acts on the ranks of the data. And ordinal data, if you remember, is essentially data that is in rank order, but the distances between them are not necessarily known. Okay, so as I said, there are other options of what you can do descriptively in this module. You can make some basic plots, for example. So we could, for example, plot some distributions, or we could plot some correlations, and you see these automatically appear down here. There's various things you can do and play around with, but for now I'm going to leave it there, and you can explore, have a look in the JASP guidebook, and have a think about what's appropriate for any kind of analysis that you're doing. In the following videos, we'll move on to each of the study designs, and there will be a video to accompany each of the videos that talks through how the general linear model is equivalent to certain kinds of statistical named tests that would be used for those kinds of study designs.